So today we're going to review the fundamental theorem. This can all be found in section 5.4 of your lecture guide. We aren't going to go through as many examples as we are just going to touch on some of the basic processes of the fundamental theorem and what it entails. So let's get started. By definition, the fundamental theorem of calculus makes a connection between rates of change functions and accumulation functions, or antiderivatives. So more specifically, it states that for any continuous function of f with input t, the derivative of a to x of f of t d of t is the function f in terms of x. So what you should notice from this is that our derivative variable, in this case x, from our d of x, is different from our function variable inside parentheses, in this case t from f of t. But through using the fundamental theorem of calculus and its notation, we see that our result is f of x, where we've substituted this derivative notation variable in for our function notation variable. Here are two simple examples from your book that we're going to look at. So to start, say you're given g of r is a continuous function. From 6 to x, g of r d of t. If you notice, it's really just this simple. You have the d of x and then your g of r. You're simply substituting this derivative variable, or x, in for your function variable, or r, to give you g of x. So in your second example, it's literally the same thing, even though it might look a little bit more involved. You'll see that your answer is, instead of your original t to the fourth plus 2t squared plus 7, you get that same exact function, just with x substituted in. So you get x to the fourth instead of t to the fourth, and so on. The purpose of doing this is that we're establishing a relationship between differentiation and integration. So along with the fundamental theorem, we associate antiderivative rules because these help us define specific antiderivative equations from word problems. 4 basic rules are outlined in this section. These are the simple power rule, the constant multiplier rule, and the sum and difference rule. So to start, the simple power rule states that for any value where n does not equal -1, the antiderivative of x to the nth power is equal to x to that nth power plus 1 over this new exponent, or that n plus 1, plus c being your constant of integration. So if you look in the rightmost column of this table, you'll see a more specific example. In this case, it gives us x to the third power. As we talked about earlier, you're going to take this 3, this original n exponent, and you're going to add 1 to it to give you x to the fourth. And then you're going to divide that by n plus 1, or your new exponent. So x to the fourth divided by 4 plus c, or your constant of integration. So for the constant rule, it just states that when given a constant k, your antiderivative is going to be this constant times x, so k times x. In our more specified example to the right, you see that they give you a constant 5. Your antiderivative is simply this 5 times an x variable. For the constant multiplier rule, it states that if you have a constant k times an expression f of x, you can kind of detach this constant of k and move it outside the integral sign. This is really just kind of a notational thing. It's kind of how you write it. So if you see in our more specific example, it gives you 2x to the third. This 2 is representative of our constant k, and this x cubed is our f of x value. So you can detach this 2, this constant k, from our f of x, or x cubed. And then finally, for our sum and difference rule, it states that if we have f plus or minus g, this kind of function, then our antiderivative is simply going to be the integral of this f expression plus or minus the integral of our g expression. So to put it really simply, in our more specified example, it gives you the expression x plus 1. So we're just kind of going to separate this into 2 expressions on either side of this addition sign. So you take, for your antiderivative, the integral of this x variable plus the integral of your 1 value. Today we discussed the fundamental theorem and the most basic skills you should understand to be successful. Your next steps are going to be applying this knowledge to finding solutions to problems such as specific antiderivatives. If you'd like some more individualized help, feel free to make an appointment with a tutor through the Academic Success Center, and they can give you some more tailored support.